Imagine strapping a rocket to the back of an aircraft and hoping for the best. That's exactly what desperate Navy engineers did in the darkest days of World War II, and what followed changed naval aviation forever. December 1941. Pearl Harbor lies in ruins. America's Pacific Fleet is crippled. The Navy faces a terrifying reality. Their carrier-based aircraft are too heavy, their decks too short, and their enemies too close. Pilots are dying not from enemy fire, but from simply trying to get airborne. Something has to change, and it has to change fast. Enter JATO, Jet-Assisted Takeoff. The name sounds sophisticated, doesn't it? But make no mistake, these weren't jets in the way we think of them today. These were bottles of pure, controlled chaos. Rockets strapped to aircraft fuselages, filled with volatile chemicals, designed to provide just enough thrust to get a fully loaded bomber off a pitching carrier deck. The concept was simple. The execution was anything but. The story begins not on a carrier deck, but in the California desert. The Guggenheim Aeronautical Laboratory at the California Institute of Technology, or GALCE as it was known, became ground zero for American rocket research. A group of ambitious young scientists and engineers, led by Theodore von Karman, began experimenting with rocket propulsion. Among them was a brilliant but eccentric chemist named John Whiteside Parsons. These men weren't just pushing boundaries, they were inventing them. The early experiments were, to put it mildly, terrifying. Picture this: a small aircraft sitting on a desert runway. Underneath its fuselage, a crude rocket motor assembled from parts that looked more like plumbing supplies than cutting-edge technology. The fuel? A mixture so unstable that it could ignite from static electricity. The safety protocols? Virtually non-existent. The researchers would light the fuse, quite literally, and run for cover. Sometimes the rockets worked. Often they exploded. Occasionally they did both. But the Navy was desperate. By 1942, the service needed every advantage it could get. Standard carrier operations required aircraft to be as light as possible for takeoff. That meant reduced fuel, fewer bombs, limited ammunition. Pilots were sent into combat at a severe disadvantage. JATO promised to change everything. If it worked, fully loaded aircraft could take off from shorter distances. Carriers could launch heavier bombers. Strike ranges could be extended. Lives could be saved. The first practical JATO units were monsters. Each bottle weighed over 100 pounds and contained enough solid propellant to burn for 12 to 15 seconds. They were mounted in pairs or clusters beneath the aircraft fuselage or attached to the sides. When ignited, they produced a combined thrust of up to 3,000 pounds. For context, that's roughly equivalent to adding another engine to most World War II aircraft. The acceleration was violent, the noise was deafening, and the risk was astronomical. Naval aviators approached JATO with a mixture of excitement and dread. On one hand, these rockets meant they could carry more ordnance, more fuel, more everything. On the other hand, they were essentially flying with bombs strapped to their planes. Bombs that were supposed to explode, just in a controlled manner. The difference between a successful JATO launch and a catastrophic fireball was often measured in milliseconds and luck. The first operational tests aboard carriers were exercises in controlled chaos. Deck crews had to learn entirely new procedures. How do you safely handle rocket motors on a pitching deck in the middle of the ocean? How do you install them on aircraft in high winds? What happens if one ignites prematurely? These weren't theoretical questions. They were life and death realities that sailors faced every single day. One of the most harrowing early incidents occurred during testing aboard the USS Chenango in 1943. A torpedo bomber loaded with JATO bottles was being prepared for launch. The deck was crowded with aircraft, fuel lines, and personnel. Without warning, one of the JATO units ignited on its own. The bottle fired across the deck like a missile, missing sailors by inches, before finally burning out against a bulkhead. The aircraft it had been attached to lurched forward, nearly crashing into other planes. Miraculously, no one was killed. But the incident drove home a crucial point. JATO was as dangerous to the people using it as it was helpful. Despite the risks, the technology improved rapidly. Engineers refined the propellant mixtures, making them more stable. They developed better ignition systems that reduced the chance of premature firing. They designed mounting hardware that could withstand the tremendous forces involved. And slowly, JATO went from experimental technology to standard equipment. By 1944, JATO-assisted launches were becoming routine on American carriers across the Pacific. The PBJ Mitchell bomber, the TBF Avenger, and even some fighter aircraft were regularly using rocket assistance. The impact was immediate and measurable. Strike aircraft could now carry full bomb loads on missions that previously would have been impossible. Carriers could launch aircraft in weather conditions that would have grounded them before. The tactical flexibility this provided was revolutionary. But JATO's contribution went beyond just helping planes take off. It fundamentally changed how naval strategists thought about carrier operations. Suddenly, the size of the carrier deck mattered less than it had before. Smaller escort carriers, previously limited to defensive roles, could now launch meaningful strike packages. This meant more carriers could be built faster and deployed more widely. The economics of naval aviation shifted dramatically. The human cost of this revolution cannot be ignored. Dozens of sailors and aviators died in JATO-related accidents during the war years. Deck fires, premature ignitions, structural failures, and pure bad luck claimed lives on both training missions and combat operations. Each accident led to new safety protocols, better equipment, and harder lessons learned. The men who worked with JATO every day knew they were gambling with their lives. They did it anyway because the alternative was worse. One pilot, a Navy lieutenant named Harold Fisher, described his first JATO-assisted takeoff in his personal diary. He wrote that when the bottles ignited, it felt like being rear-ended by a freight train. The aircraft didn't accelerate so much as it was thrown forward. The G-forces pinned him back in his seat. The roar drowned out even the engine noise. And then, just as suddenly as it began, it was over. The bottles burned out, fell away, and he was airborne with a full bomb load headed toward a Japanese-held island. He landed safely that day. Many others did not. As the war progressed, JATO technology spread beyond just carrier operations. Land-based aircraft used JATO bottles to take off from damaged runways or from airfields at high altitudes where thin air reduced engine performance. Transport planes used them to get heavy cargo airborne from short jungle strips in the South Pacific. Even some experimental aircraft used JATO to achieve speeds and altitudes that would have been impossible otherwise. What started as a desperate solution to a naval problem became a versatile tool used across the entire military aviation spectrum. The end of World War II didn't mean the end of JATO. If anything, the technology became more important. The dawn of the jet age brought new challenges. Early jet engines were notoriously thirsty and underpowered at low speeds. JATO provided the extra boost needed to get these new aircraft safely airborne, especially when operating from carriers. Throughout the 1950s and 60s, JATO remained a standard part of naval aviation, continually refined and improved. The legacy of those early dangerous experiments extends far beyond the JATO bottles themselves. The rocket research conducted during World War II laid the groundwork for America's entire post-war missile and space programs. Many of the engineers who worked on JATO went on to develop the rockets that launched satellites and eventually humans into space. The institutional knowledge gained from strapping rockets to airplanes translated directly into the technology that put Americans on the moon. Today, modern carrier aircraft no longer use JATO. Advances in engine technology, catapult systems, and aircraft design have made rocket-assisted takeoffs unnecessary for most operations. But the spirit of innovation, the willingness to take calculated risks, and the determination to solve impossible problems that define the JATO program still lives on in naval aviation. Every time a Super Hornet launches from a carrier deck, every time a pilot pushes an aircraft to its limits, they're benefiting from lessons learned when desperate engineers strapped rockets to airplanes and hoped for the best. The JATO revolution was born from necessity, forged in danger, and perfected through sacrifice. It transformed naval aviation at a critical moment in history and proved that sometimes the craziest ideas are exactly what's needed to win.